Let's wait for one more minute to start, and we're there. Thank you for coming, by the way. I heard that I'm competing with the beer part of the event, so let me try to be better than that. But the combo of ISIs and beer is the best ever. My friends, welcome to Las Vegas. Welcome to Cisco Live. And welcome to my short talk about ISIS. My name is Peter, and I'm the member of the Automation Bootcamp delivery team. Essentially, what I do is deliver trainings and also create the content. This session I've put together is for those of you, targeted to those of you specifically, who tried to be friends with ISIS, but for this or that reason haven't managed to do so yet. So it's a basic and gentle introduction into ISIS. If there's somebody here who knows it already, please forgive that I may go simple in parts. That's by design. But if you want to drill deep, then catch me after the session. I'd love to discuss the details. Okay? Before I dive into the nitty-gritty, though, a shameless ad. You will have heard about CiscoU a lot over the Cisco Live. It's our new offering for personalized, tailored, and facilitated training and learning path for you. Please visit me and my colleagues here in the Learning and Certification booth. Ask about CiscoU, scan the QR codes, get your free account, try the courses that are available, and see the offering for yourself. You may be very pleasantly surprised. This being said, let's go to ISIS. It's been my personal experience when teaching about ISIS that the first time the people see it, they go, ooh, what's that? It looks like from another world. And yes, they are right, because it comes from another world. It comes from the world of OSI, ESO networks that were designed sometimes in 1980s that were very different from IP networks. But since ISIS has been very nicely designed, it's very usable even today. But still, when you look at it, you feel a little awkward because you look at the vocabulary, and that one is, as they call it, the ISO speak. It's what they call it's arcane. You look at the addressing and you look like, think to yourself, what is that? You look at the concept of routing levels and tell to yourself, man, what a posh way to talk about intra and inter area routing. And perhaps you look at the way the areas work and you go, what in heaven happened here? Now, you're completely right to feel this way, but I hope that at least after this session, some of these brick walls have been deconstructed so that it's easier for you to start playing with ISIS. One thing, my goal here is to get you to the point of saying to yourself, okay, I'm willing to give ISIS a chance. I will build me a simple app and I'm going to play with it and learn more. And I'm going to even stay at that stage in this session, right? So what ISIS is without this kind of attitude? It's a very nice and lean link state routing protocol that is essentially very similar to OSPF in its fundamental basics. And that's not because OSPF would be inspiring ISIS. It went the other way around. ISIS was before OSPF, and OSPF got inspired in many ways. However, they both implement the same fundamental principle, which you can hardly do in another way. Of course, there have been implementation choices made, and so ISIS is outwardly different than OSPF, but in its core, they tick in a very similar way. However, inside the machinery of ISIS is way simpler than OSPF. And unfortunately, we don't have the time to dig deep, so I just ask you to take my word for this. However, the extensibility of ISIS is way better than any other IGPs I know. And by the way, I'm also a very strong EIGRP guy, but I have to say ISIS is even more easily extensible than EIGRP, both in terms of what you can transmit up and back between the routers, the kinds of IP addresses or other addresses, for example, MAC addresses, and also in terms of how you can extend and enlarge your complete network. It's way easier to extend an ISIS RAN network with new areas than it is with OSPF. So that I can talk and show you something from ISIS, I need to go through a vocabulary, and I ask you to bear with me because, yeah, this is boring, but it will bring its fruit later. So, when we speak about system in ISO speak, we mean a network device, the one that in IP world would get an IP address for itself. When we talk about end system, we mean an end host. I don't know, a computer, workstation, printer, you name it. And if we talk about intermediate system, we mean a router. So ISIS as an intermediate system to intermediate system is really the communications of routers to each other. When we speak about circuit, a circuit is a synonym for interface. A domain is a synonym for autonomous system. They can be used interchangeably. Net or network entity title, this is something we will be looking into in more detail. Network entity title is an OSI style of address assigned to routers. And it's going to be important for us because for ISIS, it contains the area ID, the area, and also contains the router ID. So we will be looking into it more closely since ISIS needs that. And finally, there are those routing levels. Routing levels are the scopes of routing that ISIS is taking care of. And we talk about level 1 and level 2. Level 1 routing is routing inside an area. Level 2 is routing between areas. Don't confuse this with layers, okay? Layers are different thing. Levels are something different. We're talking about levels here. This is by far the worst slide. I promise you it's gonna get only better. I need to talk a little about those OSI addresses that are formally called Network Service Access Points, or NSAPs. They are very different from IP addresses, but also very interestingly different. There is only a single NSAP address assigned to a device as a whole, not a interface or per interface assignment. So this means that no matter how many interfaces a router has, it will only have a single NSAP address. It's a little weird because this way we don't have a concept of subnets and common networks. But let me tease you a little. We can do this also with IP networks. Do you have an idea how? And hint, you would need IPv6 for that. Any idea how we could do something like this work? A single address for a router, no matter how many interfaces it has. And still it works. The routers can talk to each other. Well, here's an idea. You would run IPv6 on all those routers, but on the physical links that connect the routers together, you would leave just the link local addresses. You wouldn't assign any manual addresses yourselves. But you would create a loopback for every router and assign one global address for a router on this loopback. And finally, you would run any routing protocol for IPv6 you would want. What would you end up with? A single address for a device that is advertised between everybody else, and you can talk to it. And since your routers don't have global addresses on the links, they would not show up in the routing tables. This OSI addressing worked very similarly. That was the one interesting thing about it. The second interesting thing about this OSI addressing is that it has a very flexible structure, and that's why it's also the length of the NSAP address can be anywhere between 8 and 20 bytes. Imagine that back in 1985, we could have had 20-byte addresses. Now we have 16 bytes in IPv6 and we're happy. So it's very flexible, but the basic format is this. The first byte of this NSAP address, highlighted in red, is the number that tells you how to interpret the whole remainder of the address. We call it the authority and format identifier. We will always see the number 49, which is something like a private address. And that means that you can do the rest of the address completely the way you want. You don't need to abide by any formal structure. Then the bluish part there in the two examples is the area ID. Now you may notice that in the first example, it has 2 bytes, 0001. In the second example, it's longer, it's 6 bytes. I'm not going to read it. How do I know it's 2 or 4 or 6 bytes? Give me a minute, I'll tell you. What follows, though, is 6 bytes of system ID, and this is the identifier of the router inside the area that has just been described by the beginning of the address. This will always be 6 bytes. And finally, the last byte is what we call the network selector, and it used to select a specific network service you wanted to talk to on the router. If this byte is 0, and we will only see the byte with 0, we call this network address a network entity title, because it doesn't indicate any specific service, just the box as a whole. It's the easiest to read these addresses from right to left, meaning you will always see the 00 at the end, that's the network selector, you don't care. The 6 bytes before that, that's the router ID. And then all the rest till the left part of the address, that's the area. Done, simple. So the addressing could look, for example, like this, just pardon me, cannibalizing a little old Netiquette slides for the 39 instead of 49 in the slide here. Notice how this could look like. You would have a couple of areas that your network consists of. Routers inside a given area started with the same area ID, 390001, 390002, or 3 or 4. Okay, that's area ID, done. Then you have 6 bytes of router ID, 111, so all ones or all twos, I don't know, all nines, for example, and so on. And .00 at the end. And that's enough what we need to know about this OSI addressing. Why do we need it? Because to ISIS, they are the source of the information about the area that the router is in and its own router ID. Well, they call it system ID, but that's the same thing. And ISIS needs to know this so that it knows what other neighbor it talks to and whether the neighbor is in the same area as we are. There will be one and only one such network entity title configured inside ISIS process, and we're done. What does this mean? Since there is one network entity title for the whole router, including all of its interfaces, will be in a single area. This is different from OSPF, because in OSPF, the area boundaries are on routers. Some interfaces are in area 0, other interfaces are in different areas. That's OSPF. In ISIS, the whole router, including all of its interfaces, is inside a single area, and so the area boundaries are on links. And it feels more like autonomous systems in BGP, where also the boundaries of the autonomous systems are also on the links, not on the routers. However, this network entity title is only a parameter for ISIS. It doesn't mean that when you configure it, it somehow forces your IP network to also run some OSI protocols or enforce some additional addressing scheme on top of your IP. Not at all. This is, while it's a mandatory parameter for ISIS to work, because my area is in, my system ID is in that network address, that's where it ends. It doesn't interfere with your IP. All right? So, this all has been foundations on which ISIS is based. Now, technically, what are some of the important technical properties of ISIS? Essentially, it's a link state protocol, or if I was to be very exact, it's a hybrid, just like OSPF, because inside area, it works in this link state manner. I know precisely how many routers are there, and I know precisely how the links run inside area, just like OSPF. That's link state. But regarding other areas of the network, I know that there are some prefixes, that there are some networks, and I know how far they are, but I have no clue about the topology. That's distance vector. So when you combine it together, it's okay, link state inside area, distance vector between areas, which is a hybrid, exactly like OSPF. ISIS, and this is very interesting, inserts its messages directly into frames, such as Ethernet. It doesn't go through IP and then something else. It also doesn't go through the OSI protocol that was the equivalent of IP. They call it the CLNP, Connectionless Network Protocol. No, ISIS goes directly into frames. It doesn't depend on IPv4. It doesn't depend on IPv6. It doesn't depend on anything. It just runs. That's why it's so easy to extend it with the understanding of new protocols, IPv4, IPv6, and who knows what comes next. And finally, it's a multi-protocol IGP truly because it's very easy to add information elements to its bodies that simply advertise a new style, a new way, a new format of addresses that you need to carry. Right now, ISI supports IPv4, IPv6, MAC addresses for certain applications, and also other types of information. Okay, I want to stop the slides now. I've got a simple network running in the backstage. A part of it is configured for ISIS. One router is not. And I'm simply going to show you what's necessary to do on this router as a minimum to bring it up and start talking to its neighbors. I am not going to tell you how the network looks like because if we have time a little, we'll be able to tell how the network looks like based on the ISIS outputs. It's that easy to interpret it. So my question, is it visible and readable even in the back rows, or should I make the letters larger? Good, I'm good, fine, thank you very much. So I'm going to only tell you that this router has one neighbor, it's R2, and it's connected to my interface, Ethernet 00. I want to start ISIS here, and I know that the guy is already configured, and I want the adjacency to come up. What do I need to do? This is iOS, and iOS XE would be just the same way. I need to assign this device a network entity title so that it knows what area it is in and what system ID it has. The area I'm here is 49. It's always going to be 49. 0001. And since it's router 1, I'm very lazy, and I just make it all ones. All 6 bytes for system ID, I'm going to assign it as simple ones. And what, somebody dropped their teeth. What value do I need to have so that this is a network entity title at the end? FF0000. Oh, no. Here we go. And second thing, I need to assign interfaces under this ISIS process. Since it doesn't really care if it's IPv4, IPv6, blah, 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 I don't use the network command here. Rather, I go to an interface and say, hey, you're a part of ISIS for IPv4 or IPv6. So I'm going to go to Ethernet E00 and say IP router ISIS. And now I'm waiting for the magic to happen. Voila, voila. And it's up. Okay, now what? First of all, you know it, we will all be trained to verify the neighborships with my ISIS or any neighbors, OSPF, via GRP, BGP even. So what do I have there? There's an information about who is my neighbor. In this case, it's R2, that it's on the interface E00, that L1 means it's level 1 adjacency. We know how to route inside this area, but we don't know exactly how to go outside of our own area. We need somebody else who is smarter. That's what it says. Notice one nice thing. The first field is system ID. It should have been a number, right? But it nicely shows me the host name of my neighbor. How's that possible? That's because ISIS loves you. ISIS knows that you don't like to read those numbers. ISIS wants to make your life easy. And in its packets that come into the log-state database and that form the puzzle that creates the map of the whole network, it also tells you its own name. And we can even display that. See? And those are my routers inside this area. I know that there is device R1, that's me, all ones. There's device named R2 and its system ID is all twos, and so on and so forth. And you can probably tell based on this output indirectly that my area, which I'm now standing in, has 3 routers. That's nice, but how are they connected? You cannot tell from this. Let's see if we can somehow dig out this information from the database. Don't get scared. I'm not going to go deep into the ISI's link state database, but I want to demonstrate one thing. The data as presented by ISIS is relatively easy to interpret. So what I have here, without going into too much detail, is a piece of puzzle that together creates the complete map of my area. Each router has one piece there, exactly one piece. Router 1 has its own, router 2 has its own, router 3 has its own. They are named equivalently. Please just skip those zeros and dashes for the moment. And I'm interested in what I'm telling to others and what others are telling to me. So if I go and pull out the information I'm telling to others so that they know, an area is almost like a village. Everybody knows everybody and everybody dumps on everybody else. And link state protocols work exactly the same way. What I tell you, you tell others, so everybody know about everybody. So this is what I'm telling to everybody else, wherever this piece of puzzle gets. What I'm telling to the others. My area address, well, that's nice. They at least know if they're together with me or not. Hey, I'm telling them my host name. That's where it comes from. I'm telling them my directly connected networks, those 2 ones. And hey, I also have an indication of who I am connected to. This is a neighborship, this is an adjacency to another router. Notice that all those metrics are 10. I didn't emphasize it before in the slide, but by default, ISIS assigns a metric of 10 to every single interface. It doesn't matter how fast it is or what kind of technology is that. So this is what I told everybody else. Everybody else knows that I'm connected to R2, and these are my directly connected networks. Fine. And let's see what R2 is telling me and everybody else inside this area. Wow, that's nicer. And it's a little rich than we had with R1. So some parts are similar. It is in the same area as I am, R2. Its name is R2. Well, perfect. I know that it has certain IPv4 networks directly connected. And hey, there are also IPv6 networks. It's all in the same piece of puzzle. This router told to somebody else. One besides the other. There are no separate instances of ISIS for IPv4 and IPv6 and something else. It's able to tell me in one go. And regarding R2's connections, it's telling me that R2 is connected to R3 and also back to R1, because from R2's point of view, it has 2 neighbors. One is 1, the other is 3. Without further ado, my area that I'm just standing in is just a chain of 3 routers. 1, 2, 3. And that's what's also visible from there. Notice that it's easy to interpret this information. If you go to OSPF and try to piece together the LSAs, you'll be sweating more. Coming back to the slides. So this is essentially the topology that I have. And we somehow could pull it out from ISIS. Now, if we do have multiple areas, I'm just refreshing one thing that I said before. We have those routing levels. Level 1 routing is routing inside an area. Level 2 routing is routing between areas. OSI networking also recognizes level 0 and level 3, but this is not something that ISIS is doing, and this is something we're not interested in either. Notice here that for area 1 to talk to area 2, we need 2 routers that are essentially allowed to talk to each other even if they are not in the same area. And what they need to do is also pick up all the networks that are in their own area and just advertise it further so that they know what's behind that area. And this is essentially what is a backbone in ISIS. We don't have, as opposed to OSPF, a dedicated central backbone area to which everybody else needs to connect, like in a star fashion. But in ISIS's case, the backbone is a contiguous sub-part of your network that, well, I don't like this word, but it gets the point. It pervades every single area that you have. In this diagram, it's those gray routers. Those gray routers are those that are allowed to have both adjacencies inside their own area so that they know what's there and pick up every single network that they know about. And they are also allowed to talk to somebody else in a different area and then advertise all the known networks from their own areas toward them. And so essentially speak on behalf of their complete area to anybody else who is there. Now imagine how easy it is to extend this network. Do you need a new area 5 underneath area 4? Just connect it there and use some router and designate it as L2 capable router, level 2 capable router. You don't need virtual links. You don't need forcibly to go to area 0. You can just be there and extend the network where you need it. It doesn't mean that extending it in a feather manner is a good idea, but you have the option. Use it wisely. That's the idea behind ISIS. So I also have another area in this topology, and I'd like to have a look at that one. But since we're also a little pressed for time, I'm only going to show you how the routing table looks like on a router that is both level 1 and level 2. This is router 3. It has a couple of neighbors. It has a neighbor 2, which is a part of its own area, and it has a neighbor number 4, which is a different area, and we know that because the type of the adjacency here, pardon me, is L2. So that means, oh, that guy is not the same area with me. He's a different area. If I check the routing table and pull out the ISIS routes, notes that, well, there is a series of routes here. Those 10, 255, 255, those are my loopbacks. I like to use these numbers because they're visibly, they just punch your eyes and say, oh, I'm a loopback. Some of them are labeled in the legend as L1, for example, this one, or this one, and this means that this route came from somebody who is inside my own area. The routes labeled L2, level 2, are routes that came from somebody who is in a different area. And if we dug deeper into the link state database, we could also show how that works. But I'm just leaving it here and explaining what you might see when you spin up an ISIS instance and see what it did when it provided you with the connectivity. And by the way, this is how the full network looks like. I've got 2 areas, and routers 3 and 4 are the level 1, level 2 routers. All the remaining routers are level 1 only, for simplicity. As I said, my goal here was to simply remove some of those, oh, what's that, type of attitudes, and allow you to start thinking of ISIS and thinking to yourself, okay, I'd like to know more. I may try something. Where can you learn more? So a couple of resources. First, discussions. Cisco community and Cisco learning network. Second to none communities when it comes to both precision of communication and courtesy. Trust me, I participated there for a long time. I know, second to none. Wonderful people, amazing experts. Trainings that are available, and also this ties back to CiscoU. Currently, we have 2 trainings, essentially for SP Core and for SPRI, which because ISIS is still mostly an SP topic, that also touch the topic of ISIS. If you are a book type, then I can note 2 or 3 books. One of them is from the one and only Jeff Doyle, OSPF and ISIS, choosing the IGP for large-scale networks. Wonderful book that compares OSPF and ISIS. So very much recommended. Another compendium is the complete ISIS routing protocol by the two gentlemen mentioned there. And if I may say so, I'm a co-author of the now too old CCI and routing and switching official certification guide, volume 1, that I co-wrote with Narbi co-charians. Chapter 10, ISIS there, I wrote it, and I wrote it from scratch, trying to cover all those things from my teaching about ISIS that I knew are hard to cover, difficult to understand, prone to misunderstanding. So if you really want to go deep with ISIS, then please allow me also to say that I think that chapter came out nice. And finally, I'd like to close with a certain thought or food for thought that I would like you to walk away with. The more you improve OSPF, the more you get ISIS. Thank you.